Welcome to Homework Lib.
In this problem, we have been given the two blocks connected through a pulley and a light string as shown here. So the mass of block 1, that is 2 kilograms, and the mass of this block 2, that's 4 kilograms. Let's represent that using M1 and M2 respectively. And here the angle of inclination is 40 degree. So we have to determine the acceleration and the tension in the string. So we need to figure out the acceleration of both these blocks. So of course they will have same acceleration. So let's indicate A as the acceleration. That's what we need to determine. And here we will consider all the surfaces to be smooth because we have been given no idea about the friction force. So we draw the free body diagram representing all the forces that's acting on each of these blocks. So there will be weight that will be 4 times the acceleration due to gravity, which is 9.8. So we multiply 4 with 9.8 to get the weight here as 39.2 newtons. And there will be tension that will be along the string, and tension will be same because here the string is same. Also here the weight of this block 1, that will be 19.6 newtons. And here we need to observe the component of the weight in the perpendicular directions. So by geometry, we observe that this angle is 40 degree. And here when we multiply 19.6 times cos 40 degree, we observe the normal force coming out to be 15 newtons, and multiplying 19.6 with sine 40 degree, we're going to get here 12.6 newtons in this direction. And applying Newton's second law to both these blocks, the net force is equal to mass times the acceleration. So if we apply this law to block 1, and here we observe that the net force is in the upward direction along the incline, and that will be T minus 12.6, and that's equal to the mass times acceleration. And let's mark it as equation 1. So applying Newton's second law to this block 2 as well, the net force is 39.2 minus T, and that's equal to its mass times the acceleration. So first we add these two equations so that we can eliminate T and figure out A. So adding this, we're going to get here 39.2 minus 12.6, and that's 26.6, and that's equal to 6A. So here when we divide 26.6 with 6, we're going to get the acceleration coming out to be 4.43 meter per second square approximately. And now let's take this value of acceleration and put it in equation 1, let's say, to get the tension. So that will be T minus 12.6, and that's equal to 2 times of the acceleration, which is 8.86. And here when we add 8.86 with 12.6, we can get the value of the tension force coming out to be approximately 21.5 newtons.